All right, welcome to The Explainer. Today we're going to talk about AI, but not in the way you might think. We're not talking about code or algorithms, not really. We're talking about economics. We're going to explore this really fascinating idea that today's super powerful AI might actually be built on a foundation of incredible waste. And, more importantly, how a simple economic shift could totally change the game.
So let's just dive right in with a big question. We all know today's AI is powerful, right? I mean, it's incredible. But what if it's also unbelievably wasteful? What if there's this huge hidden cost? We're not talking about a small problem here. This inefficiency, it could be the main thing holding us back from the next big breakthrough in AI.
Okay, so this is really the core idea, the big shift in thinking we're talking about. On one hand, you've got the old way of doing things, which is kind of like a rigid command economy. Think brute force. It has to activate everything for every task. On the other hand, there's this new way of thinking, which is much more like a flexible market economy. It's all about leverage, about activating only the parts you actually need. So what does that really mean when we're talking about an AI?
So let's talk about that command economy model. What makes it so incredibly expensive? Why are these massive AI models just so resource hungry? Well, it all boils down to how they're built, their fundamental architecture.
So get this, to do something as simple as generating one single word, a big model might have to fire up millions, maybe even billions of connections inside its network. That's insane. It's like calling an all-hands meeting for your entire company, every single person, just to figure out where to order lunch, Most of those connections, most of those people are completely irrelevant to the decision, but they're all activated anyway. It's just a huge, huge waste of energy.
And this quote just hits the nail on the head. It reframes the whole problem, doesn't it? The expensive part isn't thinking or being intelligent. The real cost, the killer, is trying to coordinate millions of tiny little pieces that don't have a manager, that don't have a high-level summary. There's no abstraction, it's just organized chaos, and that chaos costs a fortune in computation.
Okay, to really get a grip on why this is so inefficient, let's use an analogy. This one's pretty good. Picture all of the AI's knowledge being stored in this absolutely massive warehouse.
So the root of the problem is something called partitioned information. It's a fancy term for a simple, kind of messy idea. A concept, let's say photosynthesis, isn't stored in one nice, neat little box. Nope. Instead, its meaning is basically shredded into thousands of tiny little pieces and then just scattered everywhere across the entire warehouse. So no single part of the AI actually knows what photosynthesis is.
This is where the shredded book analogy comes in. Imagine taking a book about photosynthesis, putting every single page through a shredder until you have just individual letters, and then just throwing all those letters randomly around that giant warehouse we talked about. Now, what if you wanted to read just one paragraph? Well, you'd have to walk through the entire warehouse, find every single correct letter in the right order, and piece the whole thing back together from scratch. I mean, it would work, eventually, but what an unbelievably inefficient way to read a book.
Okay, so that's the problem. That's the super inefficient command economy. It's a mess. So what's the fix? How do we get to that smarter, faster, cheaper market economy? Well, the answer is actually pretty elegant. You create a map.
Think about it this way. The old brute force method, it's like if every time you wanted to plan a road trip from, say, New York to LA, you first had to calculate the distance between every single city on Earth from scratch. Paris to Tokyo, London to Cairo, all of it, every single time. It's just pure, unnecessary work.
And the new way? It's so much simpler, it's almost funny. You just use a map. That's it. The map already has all that information. All the relationships, all the distances, they're already baked right into its structure. All you have to do is look.
So in the world of AI, this brilliant, efficient map has a name. It's called latent space, and it's a real game changer. You can think of it like this compressed, abstract map of everything the AI knows. And on this map, ideas aren't a process anymore. You don't have to reassemble them from shredded bits. Meaning becomes a place, a location. So if you want to know about photosynthesis, you just go to the photosynthesis neighborhood on the map. Simple.
And as you can probably guess, moving from this constant, painful recalculation to just, looking at a map, it has a huge economic payoff. The savings are just massive. So let's break down where that efficiency actually comes from.
So you get these huge savings in basically three main areas. First, and this is a big one, Way fewer connections need to be active for any given task. And because of that, you get a massive drop in the number of raw calculations the AI has to do. And finally, all that overhead, all that energy spent just trying to coordinate the whole network, it just plummets.
Let's go back to that company meeting analogy for a second. The old way, the dense brute force way, that's forcing every single employee into every single meeting. It's a complete nightmare of wasted time and money. The new way, the latent space way, that's like having smart, skilled managers. You delegate the task to them, they figure it out, summarize the important stuff, and then act. You're getting to the exact same goal, but with a tiny fraction of the cost.
All right, this next part is where things get really deep, because what we're talking about here isn't just a clever trick to save on a power bill. This is a truly fundamental shift in how we think about what intelligence even is.
Think about how we learn things as people. We tend to mix up the cost of learning something with the cost of using it. For example, it takes years of hard work for a kid to learn a language, right? That's a super high learning cost. But once you're fluent, speaking a sentence takes almost zero effort. The usage cost is incredibly low. And that's exactly what latent space is for an AI. It's the moment it achieves fluency.
And you can feel this in your own head, right? When you're confused about something, your brain is firing on all cylinders, trying to connect everything to everything. It's a sign of confusion. That's dense activation. It's like your mind is just spinning its wheels.
But then you have that aha moment. You get it. And suddenly you know exactly which couple of ideas you need. You're only activating the relevant parts of your brain. That's sparse activation. It's not just efficient, it is the very feeling of clarity, of mastery. So what this all means is that this efficient process does something really profound. It completely transforms the very nature of knowledge inside the AI. What it's really doing is turning all of those many fragile connections
Into just a few robust, powerful abstractions. It's taking a million little threads and weaving them into a few strong ropes. These are our managers. These are the cities on our map. They're powerful, reusable concepts.
And this is the ultimate punchline. This is where knowledge stops being an expensive process that the AI has to run every single time, and it starts being capital. It's an accumulated resource, something the system has built up that it can now draw on and invest with almost no effort at all. So this completely turns our definition of machine intelligence on its head. Real intelligence, it turns out, might not be about having the most computational power, about being able to calculate everything. No. Maybe true intelligence is about being able to compute almost nothing and still get the right answer. It's about being efficient. It's about leverage.
And that brings us to one last, really big thought to leave you with. If meaning becomes capital, what happens when our machines stop paying for every thought with raw computation and instead start living off the interest of their accumulated intellectual assets? What kind of future does that create when our machines become the ultimate, most efficient intellectual investors we've ever seen?